Hi guys. So let's look at this problem called permutation with arrays. So we are given a number n and we are given two arrays A and B. Each is having same size, like both of them are having the same size of n numbers. And then all we are asked to determine is if B is a permutation of A or not. So what's a permutation? Permutation is essentially an arrangement of all or part of a set of objects. Might not be clear from the definition properly, but from the examples, you can see 213 and 321 are permutations because if you sort both of them, they will be identical. That's one way to look at it. Um, and so the number of test cases is 10, and the max size of A and B can go up till 3 into 10 power 5, and the domain of A and B can range from 1 all the way through 10 power 7. Okay. Now, yeah, let's look at one test case to make it clearer. So let's look at these two test cases, 4237 and 2349. The way we can determine if two arrays are permutations of each other or not is uh, if we sort both of them and we compare element by element, they should be identical. That's the sufficient condition to show that both of them are permutation of each other. For example, here we just sort both the inputs 2347 and 2349, and then we element wise compare them, and we realize that the last elements are different, and that suffices to say these are not permutations of each other. Okay. And if we look at the second example, second test case, again, we sort both of them. And if we do the element-wise comparison, these are exactly the same set of numbers. The frequency of each of them, each of the elements are all same. That's another way to say the same thing. Um, but it's very, it's very easy to see if we see it through this lens that just sort them if they are identical by comparing them element by element, we can simply say yes or no. Okay. And that will exactly be our algorithm to determine if two arrays are permutations of each other or not. So what we will essentially do in the optimal approach is we sort both of them. Each will cost n log n, and then we simply check element by element. We just iterate um, iterate on the indices 0 all the way through n minus 1, and we check if AI is equal to BI or not. And thereby we can say if they are permutations of each other or not. And it will cost us n log n per test case, right? So let's look at the code quickly. Um, this is exactly what we saw in the slides. I can remove this because going over that other approach, but yeah, it's not of use. So we take the input of n, we take the input for A and B, we sort them, and we initialize the a flag called both are same as true, and then we just iterate over the indices. It's just sufficient to say if there exists an index where AI is not equal to BI. Yeah, it's sufficient to say that they are not same, and we break out. Um, and based on this flag, we just report yes or no. So that's the complete code. It's an accepted code. And we also have discussed the time complexity, and the space complexity is essentially order one. We are not taking any extra space. We are simply sorting the arrays A and B in place. So the space complexity will be order one. So that completes the solution video for this problem. Thank you for watching.